I would need to start recording, or need to start recording, such that even if some of you are missing it, you'll be able to catch up later. So, hello everyone, and this is the walkthrough session for the second JMC mock that we're doing. So this second paper, I would say that it is slightly easier than the first one we have. So I would say that it's kind of similar to a JMC paper in general, because like from what I get from your results, I can see that most of you are getting a score around 100, like 90 something, 100. So that's the average score of all of you. And that average score is pretty much similar to everyone's average score for the JMC papers. So I would say that this mock paper is more or less similar to the JMC papers in terms of difficulties or in terms of the coverage. All right, so let's get started talking about this paper. So we have the first question. This is really an easy one, but you know, like usually the JMC papers also start with the easy questions. So that's the reason why I have it here. And it says that the longest match lasts a total of 11 hours and 5 minutes, which is clearly just a time conversion question. And that's going to be, we know that 11 hours is 660 minutes, for each hour being 60 minutes. So we have 11 times 60, adding 5. And that's going to be the total number of minutes it has, which is going to be 660, adding 5. And that's going to be 665, right? So the first answer is going to be C. Okay. And then for the second question, I would say that surprisingly, this one has got a pretty low accuracy. I think it's only about 70 of you guessing it right. So to be fair, it's a little bit shocking to me, but let's see how are we gonna calculate this question. So you can see that we have 0.000315 multiplied to 7,928,564. And we want to know which of them is the product closest to, which means that it is going to be an estimation question. So for an estimation, I can say that it's equivalent to 0.0003. Ignore this. That's just an error there. Multiplied by 7,900,000, which is like about 8 million, right? So you can estimate it as 8 million. And then the next step is, of course, I would like to make this decimal disappear and turn it into an integer for easy calculation, right? So we need to move 1, 2, 3, 4 places for the decimal point, such that it becomes 3. Which means that if I want to find the same answer, I need to remove 4 places for the other multiplier. So it's going to be equal to 3 times 800. All right. So moving the decimal point 4 places to the right for one of the multipliers implies moving the decimal point for 4 places to the left for the other multiplier, such that you're having a constant product. So that's 3 times 800, which is 2,400. So the answer is going to be D. All right, for the second question, the answer is D. And then that's the third question we are looking at here. Which of these 5 numbers is the largest? We don't actually need to calculate it. First of all, if you're adding a number, is it going to be bigger or smaller? It's going to be bigger, right? So it might be A. For the second one, if you're subtracting a number, it's going to get smaller. And for the third one, when you're multiplying something with a fraction, is that going to get larger or smaller? Clearly, it's going to get smaller. For example, if you are multiplying something by a half, an integer by a half, it's just going to be half the value of the integer. So it will be smaller in this case. And as for D, when you're dividing a fraction, it would be equivalent to multiplying the reciprocal of it, which is 2,468 over 1, which is equal to 2,468. So definitely it's going to get super big. So like I'm going to put 3 arrows there, super big. And definitely that's going to be greater than that number adding a small fraction, or that number with a little bit of decimal tail to it, even though these two are also making it greater. So the answer is definitely D, because I have a 5-digit number multiplying a 4-digit number, and that's going to be super big. All right. So that's for the third question, D again. And then for the fourth question, this is the fourth question we have. Most of you are getting this one right. So it says that the angles of a triangle are in a ratio of 3 to 3 to 4. What is the degree measure of the largest angle of the triangle? So we know that the interior angle sum of a triangle is equal to 180 degrees, right? It's equal to 180 degrees. And then they are in a ratio of 3 to 3 to 4, which means that I can split it into 10 parts, such that after dividing 10, I know each part is 18 degrees. And the largest angle is definitely taking 4 parts, right? Because 4 parts is the greatest part of the 3 angles. So we're multiplying 4, such that we have 180 divided by 10 times 4, which is 18 times 4, and that's going to be 72 degrees. So the answer is D, 72. Okay, and that's the fourth question. Now we're moving on to the fifth question. So the fifth question is a question on the inclusion and exclusion principles. In a town of 351 adults, each of them owns a car, a motorcycle, or both, right? So it means that everyone owns at least one of them, one of a car, a motorcycle, or both. If 331 adults own cars and 45 adults own motorcycles, how many of the car owners do not own a motorcycle? So how do we know? Essentially, we can see that among these 351 adults, there are only 3 types of them. So let's say this circle is for owning cars, and this circle is for owning motorcycles. Altogether, the 2 circles combined will have contained 351 of them. And which part of it represents the car owners which do not own a motorcycle? It's this part, right? So the moon shape that I'm drawing represents the car owners who do not own a motorcycle. Because like for the overlapping bit, it means both, right? For the right-hand side moon shape, it means motorcycles only. So for the moon shape that is in green that I have just drawn, it means car only, right? And that fits car owners who do not own a motorcycle. So if I know that the 2 circles altogether is 351, the green moon shape will be 351 take away everyone who has a motorcycle, which is 45 of them. And that's going to be the remaining, which is 306. So the answer is D again. 306 of them are car owners who do not have a motorcycle. All right. That's just how we work this question out. And then moving on to question 6. I think this should be question 6. which triplet of numbers has a sum not equal to 1? So this is a simple calculation problem. For the first one, option A, we can convert it into 3/6, 2/6, and 1/6, which adds up to 6/6, and that's equal to 1. So this is equal to 1 as for the sum. For the second one, 2 adding -2 is going to cancel out each other, so that's equal to 1. For the third one, 0.1 adding 0.3 adding 0.6, that's 0.10, which means that's 1, right? Of course, we don't have 0.10. And so it's equal to 1 again. For the fourth one, 1.1 take away 2.1, that's -1. -1 adding 1, that's 0. So D is going to be the answer for this question. That's not equal to 1. And if you look at the last one, -3/2 take away 5/2, that's a total of -8/2, which is equal to -4. Adding 5, that's also equal to 1. So D is the answer. D is the answer. All right. And the next question is a spatial imagination question. So this is question 7, right? Well, let me do a mark there in case that I'm forgetting about it. So that's question 7 about spatial recognition or spatial imagination. How do we think about this problem? So it says that the cube has faces which are painted in 6 different colors, and I can see 3 of the views. What is the color opposite the aqua face? All right, so ignore the American spelling, all right, because I'm adopting questions from AMC. That's why, but it's okay. So you can see that the red is on the top for the first one, and then the red is on the right for the second one. The red is facing the front for the third one. So we are having 3 different views for the red face, yeah? And if you are comparing the first one and the third one, you can see that 2 of the faces are the same, red and green. But in the first one, you can see that P is facing us. In the second one, you can see that B is facing up. So by comparing these 2, you can see that the third one is what we get after rotating the first one towards us, such that P is at the bottom and R will be facing us, where G is still on the right-hand side of it. So it means that P and B are connected for the opposite faces, all right? So B and P are the 2 opposite faces of the cube. Does it make sense? So that's what we have for the first clue. And now, if you compare the second cube and the third one, you can see that blue and red shows up in both of them. But for the second one, W is facing us. For the third one, G is facing right. So the direction of BR is like this, yeah, in the 2 cubes. So you can see that if I have compared these 2 cubes, I can see that the third one is obtained from rotating the second cube towards the left for 90 degrees, such that B is still on the top, but red is facing us, and green is facing the right, which means that white is facing the left. So we have another pair of opposite faces, white and green, yeah, by comparing these 2 views. So if brown is opposite purple, white is opposite green, it means that aqua is opposite red. So the answer is red. The color of the face opposite the aqua face must be red. So the answer is A for this question 7. All right. So you just need to fix 2 of the faces and try to see which side of the two faces is the third one on when you're trying to compare them, such that you can determine the relative positions for these cubes, right? And then for question 8, this is just a question on defining new operations. So you might see these kinds of questions, or you might not, but it would be pretty much similar to those kinds of function machines questions as well. Basically, the question is giving you a rule, telling you what to do for these kinds of operations. So nothing too special about it. Is that A at B represents the operation of A times B over A adding B for any A and B being positive integers. So what is 5 at 10? Easy. All we need to do is just to do a simple substitution. So you can also say that it's, well, you can say it's calculation. You can say that it's the algebraic skills. So basically all you need to do is to substitute 5 for each A we have and 10 for each B we have, such that in the end, we have 5 times 10 over 5 adding 10, which is equal to 50 over 15. And we can simplify it such that it is 10, this is 3, so it's 10 over 3. D is going to be the answer to this question. All right, that's question 8. And then for question 9, this one is a simple logical deduction problem. It says that Bridget, Cassie, and Hannah are discussing the results of their last maths test. Hannah shows Bridget and Cassie her test, but Bridget and Cassie don't show theirs to anyone. So it means that Bridget and Cassie both know the result of Hannah, but that's the only thing they know. So if Cassie knows the result of Hannah, and Cassie says that she didn't get the lowest score in the class, what does it mean? It means that Cassie has a score that is greater than Hannah, right? Does it make sense? And Bridget says she didn't get the highest score. What does it mean? Because Bridget only knows the score of Hannah, but not Cassie. So if she already knows that she didn't get the highest score, it means that Bridget gets a score that is lower than Hannah. So combining these two expressions, if Bridget is lower than Hannah and Cassie is higher than Hannah, so what's going to be the order from highest to lowest? Cassie is greater than Hannah and Hannah is greater than Bridget. So D is going to be the answer again. So actually in this paper, we have many option Ds as the answer, but that's just a coincidence. I did not do that on purpose, all right? I really didn't do that on purpose. That's a coincidence. And then for question 10, this should be the question 10. What is the minimum number of small squares that must be colored black so that a line of symmetry lies on the diagonal BD of the square? So the first thing we need to do is definitely draw the diagonal BD. Right. And then what's going to be the next thing to do? So we just need to turn our head around for 45 degrees, looking at the both sides of the line of symmetry, and check which are the boxes that should be appearing on both sides. So first of all, we can see that there is one square there, two square there, above the line of symmetry, right? And there are also two squares below the line of symmetry. And none of them are corresponding to each other. Yep. And then only this square is cut into 2 halves by the line of symmetry, so we don't need to do anything to that one. So it means that for this one, I need to draw one box blank such that it is having a symmetry there. For the second one, I need to draw another box there to make it symmetrical. For the third one, I need to draw a box there to make it symmetrical. For the fourth one, I need to draw a box there to make it symmetrical. So at least I would need to draw 4 boxes. I would need to color 4 boxes black to make the whole shape symmetrical by the diagonal BD. All right. And yeah, I should turn off the annotating function there. Right. Please, everyone, don't try to add anything to my board. Otherwise, it might be misleading for the others. So that's for question 10. And then for question 11. So let's take a look at question 11. It says that the least common multiple of A and B is 12, and the least common multiple of B and C is 15. What is the least possible value of the least common multiple of A and C? All right. So basically, we know that the least common multiple of A and B is 12. It means that the lowest common multiple of A and B is equal to 2 times 2 times 3, right? And then the least common multiple of B and C is 15, which is 3 times 5. And why am I writing all of these in prime factorization? That's because out of 2, 2, and 3, I would be able to find all the factors for A and B. And out of 3 and 5, I would be able to find all the factors for A and C, for B and C. So among these, if I want to find the least common multiple of A and C, it means that I want A and C to have as few or as small values as possible, right? So it means that I want B to have a value that can be as great as possible. So what is the greatest number or the greatest factor that shows up in both prime factorizations? We can clearly see that it's going to be 3, right? That's the greatest factor that is appearing in both common multiples, which means that if B is 3, the lowest common multiple of A and C is minimum. So it can be minimum. That's what I'm trying to say. So if B is 3, the smallest value of A it can take can be 4. And the smallest value that C can take is 5. All right, we are always trying to take the smallest values of A and C such that the lowest common multiple will also be as small as possible. So the lowest common multiple of 4 and 5 is definitely 20. So A is the answer. Okay. Hopefully that's making sense to you. Because I want the smallest lowest common multiple. So I want themselves to be as small as possible, of course, which is the reason why I want the other factor apart from A and C being as large as possible, such that I am also trying to avoid A having too much of these common factors with B, as well as C with B. Okay, so that's for question 11. And then for question 12. So this one is a simple ratio problem. It says that the ratio of 8th graders to 6th graders is 5:3, and 8th graders to 7th graders is 8:5. So we can just join the ratio up by making the same quantity have the same number of parts. And then 8th to 7th is equal to 8:5. So we can see that the 8th graders are the common quantity here, right? But then in one of them, in one of the ratios, it has 5 parts, in the other, it has 8 parts. So I want to make them the same number of parts, which is going to be the lowest common multiple of 5 and 8, which means that I am expanding. Yes, Amber, you will be able to access the playback. I'll send it to the group chat later. All right, don't worry about it. So the first ratio needs to be expanded 8 times, so that it becomes 40 to 24. The second ratio needs to be expanded 5 times, such that it becomes 40 to 25. So the overall ratio of the 8th graders to 7th graders to 6th graders is going to be equal to 40 to 25 to 24. And what's that going to add up to? That's going to add up to 89 parts if you add up all the number of parts. So the smallest number of students is going to be 89, because we can't have half a student, right? We can't have half a student, and that's already the simplest ratio we can find. So yeah, it has to be an integer. Right, so that's for question 12. And then for question 13, what is the units digit or the ones digit for any product of 6 consecutive positive whole numbers? So this one is interesting. First of all, what we know that is for any 6 consecutive positive whole numbers, there will be at least 1 multiple of 5. Do you agree? Because for any 5 consecutive positive whole numbers, there will already be at least 1 multiple of 5. So if it is 6 consecutive positive whole numbers, of course, there will be at least 1 multiple of 5. Yeah. And then there will be at least 1 multiple of 2. Actually, there will be 3 of them. There will be 3 multiples of 2. So as long as I have a multiple of 5 and a multiple of 2, when I'm multiplying them together, it's always going to end with a 0. It will always end with 0. So whenever you're multiplying something that ends with a 0 with any other numbers, it's always going to end with a 0 still, right? So no matter what numbers you're picking, it's always going to be ending with a 0. That's it. So the answer is 0. Okay, so that's for question number 13. And then for question number 14, it says that 14 white cubes are put together to form the figure on the right. Complete surface is painted red, including the bottom. And now it is separated into individual cubes. How many of the individual cubes have exactly 4 red faces, which means 4 faces being painted? Now you can see that whenever you have another cube sticking to the cube, that face, like the 2 faces are sticking together, then the 2 sticking faces are not going to be red, right? So it means that if I want a cube with 4 red faces, it means 4 exposing faces. Those kinds of cubes are only going to have 2 staking faces, which means that it's going to be connected to 2 other cubes. Does it make sense? So in this kind of figures, we can see that there are 3 kinds of cubes. The first one is these 4 popping out, and they are only connected at the bottom, right? So they have 5 faces painted red. These are not the cubes I want. The second types are these one as the bottom corners, and of course the one down the bottom right there. So behind these 2 boxes. And for these bottom boxes, they are connected to 1, 2, 3 of the cubes, 1 on each side and 1 on the top, which means that they only have 3 exposing faces. Therefore, they only have 3 red faces. So unfortunately, these are also not the cubes that we are looking for. And then the remaining ones are these 1, 2, 3, 4, 5, 6 cubes that are on the sides of the second layer. So in the middle of the sides of the second layer, you can see that all these 6 cubes are just connecting to 2 other cubes on the other side, right? On 2 sides of it, such that these 6 of them will have 4 exposing faces. So the answer is going to be 6. All right, that's for question number 14. So you can say there's a dying problem in geometry, or it also requires a little bit of spatial recognition. Okay, so that's question 14. And then as for question 15, it says that Isabella must take 4 100-point tests in a maths class. Her goal is to achieve an average grade of 95. Her first 2 test scores were 97 and 91. And after seeing her score on the 3rd test, she realized that she can still reach her goal, which means that it is still possible that her average score is 95. So what is the lowest possible score she could have made on the 3rd test? So first of all, we need to know that for each single test, her maximum score, her maximum possible score is 100, right? So in order to get an average score of 95, the total she needs is equal to 95 times 4, which is 380 points, right? That's the total she needs. Now, if I want the lowest possible score she could have for the 3rd test, I would like every other test to be as great as possible, right? To cover the 3rd one up. But then we already know the scores for the first 2, so I want the last one to be as great as possible, being 100. So the minimum possibility for the 3rd test is equal to the total number of marks she needs to get, take away the test results for the first 2, and take away the highest possible score for the last 1. So that's going to be 288 altogether, which means that if I take away 288 from 380, that is going to be 92. So the minimum score for the 3rd test is 92. All right. Basically, that's the application of the concept of the average, which is the average multiplying the number or the quantity equals the total. Okay, so once you know that, you should be able to figure this question out with a little bit of knowledge to optimization problems, of course. So that's for question 15. And so far, each question is worth 5 marks in this mock. So all the previous questions are worth 5 marks, including this one. And starting from question 16 and onwards, the questions will be worth 6 points each. Okay. So this is question number 16. George walks 1 mile to school. He leaves home at the same time each day, walks at a steady speed of 3 miles per hour, and arrives just as school begins. So what is the time needed to arrive school? So the usual time is going to be equal to the distance, 1, divided by the speed, which is 3 miles per hour. And that's going to be 1/3 of an hour. So 1/3 of an hour, which is 20 minutes. That's the usual time that George is taking to walk to school. It says that today he was distracted by the pleasant weather and walked the first half mile at a speed of only 2 miles per hour. So how long is that taking? Walking half mile at a speed of 2 miles per hour. So let's say I'm just going to change another color. So the time for the first half is going to be 1/2 of a mile divided by 2, which is 1/4 of an hour, and that's 15 minutes. So how many miles per hour must George run the last half a mile in order to arrive at school? So it means that George only has got 5 minutes for 1/2 of a mile that is coming up next. So what is the speed? The speed for the 1/2 of the mile is going to be equal to the distance divided by the time, which is 5 minutes. And what is going to be 5 minutes? 5 minutes is 1/12 of an hour, right? So we have 1/2 divided by 1/12, which is equal to 1/2 times 12. And that's equal to 6 miles per hour, which means the answer is speed. All right. So for question 16, the answer is B. You can't really use intuition for this question. You need a little bit of actual calculations there. Okay. And then for question number 17, we have each of the grids, like each of the digits 1 to 4 written down once each in the rows and the columns. So a little bit like a Sudoku, basically. Every single number can't happen twice in the same row or the same column. So what number will occupy the lower right-hand square, which means this one, yeah? So in this question, we can use the line elimination that we have been talking about in the short-term course, if you have attended it. Basically, I can see that for the first column, I have 1 and 2, so I need to fill in 3 and 4. But 4 has already been written down in this row. So it means that it can't be a 4 right there. It must be a 3, and this one must be a 4. Yep. So I have completed the first column already. And for the same reason, if you're looking at the second row, we have 2 and 3 already, so we need to fill in 1 and 4, but 4 is already in the last column. So it means that the last column can't be a 4 right there. It has to be a 1, and this one has to be a 4. And since I already have 2 and 1 in the row, 1 and 4 in the column, this has to be a 3. So the last digit has to be a 2 right there, yeah? So I think I have been going through some unnecessary steps there, but it's okay, as long as I can finally get the answer. So the answer is going to be 2, all right? Basically, you just need to see what numbers haven't been used in each row and column, and you will be able to get to the answer for this one, like a simple version of a Sudoku. And for question number 18, this is question number 18, it says that a store has increased the original price of a shirt by a certain percent and decreased the new price by the same percent. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? So we can simply set the original percentage, like the percentage change as X. So it means that if I have 1 adding X% multiplying 1 take away X% is equal to 84%. So if you know the formula for the difference of 2 squares, you will see that that's equal to 1 squared take away X% squared, right? But if you don't know that, it's okay. You can just try to expand it. Expand the 2 brackets. So first of all, you have 1 times 1, that is 1. And then you have 1 times minus X%. So 1 take away X% is what you're going to have. And then you have X% times 1, which is adding X%. And then X% times minus X%, which is take away X% squared. And that's equal to 84%. All right. So you can see that these two are going to cancel out each other. And well, please don't draw anything there. Thank you for your cooperation. And that's equal to 84%, which means that after reallocating the terms, you know, X% squared is equal to 16%. All right, which means X squared, because we know that percentage is actually over 100, right? So if I have X over 100 squared, it means X times X over 100 times 100. So we can do 100 times 100 on both sides to eliminate the percentage sign. And I would say we have 1,600. So if X squared is 1,600, it means X is 40, all right? So you can just solve the equation to find the answer. Okay. That's all you need to do. That's all you need to do. Does it make sense? Okay, and then we have question 19. How many 3-digit positive integers have digits whose product equals 24? So first of all, we are just looking into different possibilities for a product of 24. So we can have 1 times 3 times 8. We can have 1 times 4 times 6. We can have 2 times 3 times 4. And we can have 2 times 2 times 6. All right, so these are the 4 different possibilities for 3 numbers to be multiplying to get 24. And all of them has to be digits, of course. So for these 3, you can see that all the 3 digits are different, right? Which means that in each of them, we have got 3 times 2 times 1, which is 6 ways of arranging the 3 digits in a 3-digit number. And for the last one, we can see that there will only be 3 ways for the 6 to be in either the hundreds place, the tens place, or the ones place. So there can only be 3 ways where the 2s goes into the other 2 places. So altogether, the total number of ways is going to be equal to 3 times 6. So these 3 multiplying 6 ways, adding the 3 ways we have here. That's 18 adding 3, which is 21. So the answer is D for question 19. All good? And then for question 20, it says that all of Marcy's marbles are blue, red, green, or yellow. 1/3 of her marbles are blue, 1/4 are red, and 6 are green. What is the smallest number of yellow marbles that Marcy could have? So if a third is blue and a quarter is red, it means that the remaining fraction, so the fraction of green and yellow marbles is going to be equal to 1 take away a third, take away a quarter, which is 1 take away 4/12, take away 3/12, which is equal to 5/12. So if the remaining number is 5 parts out of 12, it means that the number of green and yellow marbles altogether must be a multiple of 5. Such that it can be 5 parts, right? Now we know that there are 6 green marbles. What is the next multiple of 5 after 6? It's 10, right? So the smallest value of the green adding the yellow is 10, which means that the number of yellow marbles is going to be 4 if you want that value to be the smallest. So the answer is 4 for this question 20. Okay. And as for question 21, how many positive 3-digit integers have a remainder of 2 when divided by 6, remainder of 5 when divided by 9, and a remainder of 7 when divided by 11? This is a very interesting question. Basically, it's just the Chinese remainder theorem. You can see that if it has a remainder of 2 when divided by 6, after adding 4 to this number, it would be divisible by 6, right? Because it would have a remainder of 6 after adding 4 to it. And the same goes for remainder of 5 when divided by 9. If I'm adding 4 to it, it will be divisible by 9, right? So, and the same goes for 7 to 11. If I add 4 to this number, it will be divisible by 11. So it means that when I'm adding 4 to this 3-digit integer, which has a remainder of 2 when divided by 6, blah, 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 then it's going to be divisible by 6, 9, and 11 altogether, right? So what is the lowest common multiple of 6, 9, and 11? Anyone who has the idea? It's going to be equal to 198. That's the lowest common multiple of the 3 numbers. So it means that after adding 4, it can be any common multiples of 6, 9, and 11, which means any multiples of 198 after this number is adding by 4. So how many common multiples of 6, 9, and 11 are there within 100, within 1000? Because it needs to be a 3-digit number, right? So you can see that 198 is smaller than 200, which means that there will be 5 of them. 1000 divided by 198 is equal to 5 with a remainder of 10. Okay, so there will be 5 of these numbers. Each of them is 4 less than a common multiple of 6, 9, and 11. That's the common supplement type of Chinese remainder theorems. Okay. And then for question 22. This is a very interesting question. It says that Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Cheap Treats. In order to make the coupons last, she declares that she will redeem 1 every 10 days until she has used them all. And she knows that Pete's is closed on Sundays, but as she circled the 6 dates on her calendar, she realizes that no circled date falls on a Sunday. So on what day of the week does Isabella redeem her first coupon? Well, we know that every week is going to be 7 days, right? Which means that every 7 days is going to be a rotation. Now, if Isabella has taken 10 days as a period, and then for 6 of the 10 days, she never hits a Sunday. What does it mean? If she goes another 10 days, will she hit a Sunday or not? She's definitely going to hit a Sunday if she's having another 10 days, right? Because you can see that when I'm dividing a number of days by 7, there can only be 7 different possible remainders: 0, 1, 2, 3, 4, 5, or 6. Yeah. So let's say I am dividing the number of extra days on top of a Sunday. It means that she has rotated all the 6 other days apart from the Sunday itself, because 10 is not divisible by 7, right? So it means that if I'm dividing 10 by 7, it's going to be 1 with a remainder of 3, right? So it means that it will be no different as if Isabella is skipping every 3 days to redeem the ice cream cones in terms of the day of the week. So you can just count it day by day to see like which day is going to be 3 days later than a Sunday to begin with the first collection or the first redeeming of the first coupon. So Monday, Tuesday, Wednesday. The answer is going to be Wednesday. And that's how we can figure out the answer. All right, because we know that after 7 of the 10 days, definitely it's going to be going back to a Sunday again, right? So we want to trace it back in terms of what is going to be 10 days after Sunday, and that's going to be the most appropriate day to start with without hitting any Sundays. Okay, so that's why it's a Wednesday. It's kind of a smart question, I would say. But you can also use the traditional method, which is like just try to list it out, see what is 10 days after each of the days of the week, and then you can see where it's going to connect to each other. So for question number 23, this is kind of those sports game problems, or you can say that it's a counting problem, which involves like the handshakes, kind of something like that. It says that in a football conference, well, like a tournament, basically every team plays each other team exactly once. So it means that if there are a number of teams, each team is playing a number of games that is 1 less than the total number of teams, right? So if there are n teams, each team is going to play n take away 1 games because it's playing every other team apart from itself. Yeah. And then it says that a total of 21 games were played, and it's asking us how many teams were there. So if 21 games were played, it means that for each game, there are 2 participants, right? So the total number of games would be equal to the number of teams multiplying the number of games that each team has played. divided by 2, which is the number of participants for each game. And that's going to be the number of games, which is 21. So it means that if I'm multiplying the number of teams to the number of games that each of them is playing, it's going to be 42. And you can see that these two are going to be 2 consecutive numbers, right? So if I know that they're consecutive and they multiply to get 42, I can easily see that it's 7 times 6, right? So there will be 7 teams in the league. Okay, so that's for question 23. That's for question 23. And then for question 24, well, it's an angle problem. So this is about a trick that I have mentioned many times already. So I believe many of you can figure this question out on your own. So we want to know this angle, which I am only given the 40 degrees, the 100 degrees, and the 110 degrees. So if I look at this triangle first, I already know an exterior angle and a non-adjacent interior angle, which means that I can find the other non-adjacent interior angle as 70 degrees, because it's the exterior angle is equal to this angle. Let's say it's x, adding the 40 degrees, right? The 2 non-adjacent angles. So we can see that x is going to be 110, take away 40, and that's 70 degrees. And then the second step, we can use vertically opposite angles to find that this is also 70 degrees. And apply this again, such that the question mark adding 70 degrees is 100 degrees. The exterior angle equals to the 2 non-adjacent interior angles adding together, which means that the question mark is 100 degrees, take away 70 degrees, which is 30 degrees. So B is going to be the answer for question 24. All right. So that's it for question 24. And then for the last problem, 25. So this one is slightly harder. Professor Chang has 9 different language books lined up on a bookshelf, 2 Arabic, 3 German, and 4 Spanish. How many ways are there to arrange the 9 books on the shelf, keeping the Arabic books together and keeping the Spanish books together? So first of all, we can imagine that actually there are only 5 objects, like Arabic books, 3 German books, and 4 Spanish books. So let's say A, G1, G2, G3, and S, okay? Because we know that the Arabic books and the Spanish books has to be together, right? So we are actually just arranging 5 objects in different orders, which means that there will be 5 times 4 times 3 times 2 times 1, or 5 factorial number of ways, yeah? And that's going to be equal to 120 ways of arranging them. However, in each of these arrangements, we know that the 2 Arabic books can have 2 arrangements, right? There are 2 ways I can put the 2 Arabic books, 1, 2, or 2, 1. And then for the 4 Spanish books, because I'm arranging 4 things at a different order, there will be 4 factorial number of ways, which is equal to 24 ways to arrange the Spanish books themselves. So in each of these 120 ways, there will be 2 ways I can arrange the Arabic books, 24 ways I can arrange the Spanish books, which means that I'm multiplying 120 by 2 and then by 24, which means 120 multiplying 48, and that's going to be 5,760 ways. So in the end, the answer is going to be C. Okay, that's for question 25. And basically, that's everything for this paper too. So I'm going to